Good morning from Melbourne, everybody, or good afternoon, good evening, wherever you are. Welcome to the IMARC Online METS Arena Live. This is our third of the week, and a big thank you to the Victorian Government and to Mining Plus for their sponsorship of this week and the last few months of these as well. It's been a great sponsorship for us, and really happy that you could be involved. Great to see a lot of faces I recognise. A lot of them I haven't seen since Expo in 2018, and we missed it this year. But hopefully we'll be up and travelling again next year. Firstly, I'd like to introduce Pablo Schatz from the Victorian Government to start us off.
All right, thanks very much, Paul, and welcome all to this session. It's really a pleasure and an honor, and also great to see so many familiar faces and some familiar names as well. Looking forward to seeing you face to face sooner rather than later. I'm very excited to be here. We've been partnering with IMARC actually throughout the year, organizing or helping them with some of the other METS Arena episodes in the lead up to the conference, which have been very successful as well. And we certainly see a lot of value in these type of instances. And we are very excited about this specific session, which pretty much aligns with the core objectives of our Victorian Government Trade Investment Office for Latin America, which I'm very happy to be part of, which are basically the objectives to bring Australian capability and innovation to the region and add value by doing so. Also to foster partnerships between Victorian businesses and potential partners in LATAM, and what's perhaps more important, to support sustainability in the LATAM mining sector by introducing new technologies and solutions and innovations to tackle key industry challenges. So in that sense, the topic of the session today on tailings management is extremely relevant. I think that you would agree that no other topic generates so many passions and discussions, and no other technical challenge has prompted such a fast adoption of innovative solutions and technologies to face with the challenges. So very excited about the line of speakers that we managed to put together with the organizers, which include the peak industry body in the mining sector, one of the largest and most successful mining companies in Chile and Latin America, and a group of very innovative and exciting Australian METS mining technology providers, which all have terrific applications for the tailings management challenges out there. So just to wrap up this brief intro, I'm just putting an invitation on the table for you to reach out to our office, Victorian Government Office for Latin America. We're open to Australian, Latin American miners and companies that are interested in learning more about what's going on in the region, in this space, and be able to facilitate introductions and support any way we can. So the invitation is on the table. And with that, I welcome you all. Thank you very much, and hand it over back to you, Paul.
Thank you, Pablo. I'm very excited now to have Diane Tang-Lee from the ICMM. And Diane's going to take us through the global industry standard on tailings management.
Thank you, Paul, and thank you, IMARC, for organizing, and also to Pablo for inviting ICMM to be a part of this forum. Very happy and very thrilled to be able to speak to all of you today. You may be well aware that we, ICMM, co-convened the Global Tailings Review last year in response to the catastrophic tailings dam collapse in Brumadinho. The other co-conveners are the United Nations Environment Program and the Principles for Responsible Investment, PRI. The aim of the Global Tailings Review is to develop an international standard for the safer management of tailings storage facilities. The standard was developed through an independent process, which was chaired by Dr. Bruno Oberle, a former state secretary for the environment of Switzerland. He had the support of a multidisciplinary expert panel and input from a multi-stakeholder advisory group. It is informed by existing good practices and findings from past tailings facility failures. Next slide, please. The global tailings review process involved a very extensive public consultation with affected communities, with government representatives, investors, multilateral organizations, and mining industry stakeholders. As the tailings review is committed to transparency, the chair has published a consultation report that reflects the feedback received, as well as how that feedback was processed and addressed in the standard, and it's available on the GTR website. Next slide. The standard was launched earlier in August this year, and it is the first global tailings standard that can be applied to existing and future tailings facilities. It strives to achieve the ultimate goal of zero harm to people and planet, and importantly, it was endorsed by all three co-conveners. Next slide. In essence, the standard strengthens existing environmental, social, and governance ESG requirements in the mining industry by integrating social and environmental and technical considerations in a comprehensive manner that will be new to a number of regions. It covers the entire tailings facility lifecycle, from site selection to design and construction, through to management and monitoring, and to closure and post-closure. It elevates accountability to the highest organizational levels, and it adds new requirements for independent oversight. And last but not least, it also establishes clear expectations around global transparency and disclosure requirements, helping to improve understanding by interested stakeholders. And the co-conveners, because they have all endorsed the standard, we will all call for broad and effective implementation of the standard. For us in ICMM, it will be integrated into our existing member commitments, which includes third-party assurance and validation. And our members have signaled the commitment that all facilities with extreme or very high potential consequences will be in conformance with the standard within 3 years of the launch date, so 3 years from August this year. And all other facilities will be in conformance 5 years from August this year. Meanwhile, UNEP will support governments that wish to incorporate and build upon the standard into their national or state legislation and policies. And the principle of responsible investments, which represents some $100 trillion in assets under management, will also be developing investor expectations to support companies in implementing the standard. So it's our hope and ambition that it will not only be implemented by ICMM member companies, but it will be much more widely adopted across the world. So here is my last slide, just some examples of the principles within the standard, which are probably the most relevant to the topic today and for METS companies. So under the topic of design, construction, operation, and monitoring of tailings facility, Principle 4 is around the development of plans and design criteria for tailings facilities. Principle 5 includes detailed requirements around robust design and robust design that integrates the knowledge base, which should include social, environmental, and local economic context of the tailings facility. And then Principle 6 involves the planning, building, and operation of tailings facilities. And Principle 7 is around monitoring systems. So with that, I hope it gives a helpful, informative overview of the standard. And and it should also be a good segue for us to think about the challenges and opportunities that are raised with some of the requirements for this new standard. That's all from me. And back to you, Paul.
Great, thanks, Diane. Really appreciate your time and know that it's late over there, so much appreciated. What I didn't mention, sorry, was that if anybody has any questions, you can write them in the chat box on the side, and we'll come to them during the session. I'd like to introduce one of South America's biggest mining companies who are going to do a presentation from Jorge Troncoso from Antofagasta Minerals. And Jorge will present an opportunity and problem statement related to tailings management. Over to you, Jorge.
Well, thank you, Paul. Good morning, good afternoon, and good evening to everybody. Yes, my name is Jorge Troncoso. I am the corporate tailings manager for Antofagasta Minerals, and very happy and very pleased to participate in this forum on this very relevant subject and very immediate, because as we just heard, we have a new tailings standard, international tailings standard, and that is posing significant challenges, as I will mention a few as we go forward here. First of all, some introductory words about Antofagasta Minerals, AMSA. AMSA is the main private mining group in Chile. As a group, we have a copper production of between 725 to 755,000 tons per year. These come out of 4 operations, all of them in Chile. Our largest operation is Pelambres, is 60% owned by AMSA. And Pelambres accounts for about 46% of our copper production. Centinela is the next, second largest. It is 70% owned by AMSA and accounts for about 31% of our copper production. Antucoya, 70% owned by AMSA with a 10% production of the total. And finally, Saldívar, which is 50% AMSA and accounts for about 13% of our copper production. Please, not yet, please go back. Just some general words about the location of our mines, because it'll be important as we go. 3 of our mines, Centinela, Antucoya, and Saldívar, are in the second region of Chile. They're in the smack in the middle of the Atacama Desert, driest desert in the world. And Pelambres, our largest operation, is further south. Still relatively dry, but obviously not as dry as the Atacama Desert, about 2 hours north of Santiago. And I wanted to mention this because one of the challenges that we have is diversity in terms of our operations, the size of the operations, where they're located, and their context, social, environmental, climate, so forth. That is that's important, as we'll see in the challenges here going forward. By the way, just to mention that again, our largest operation is Pelambres, and it produces, it has a throughput of 160,000 tons a day. Obviously, all of that generates tailings. Our Centinela operation is essentially a district. We have heap leach. We have it has several mines, but it has a heap leach facility, but also a concentrator at a rate of 95,000 tons a day, just to give some context here. So on to the next one, please. So first of all, the 2 facilities that we see here are 2 tailings facilities for our Pelambres operation. Again, this one is located about 2 or 3 hours north of Santiago. You can see it's very steep terrain. The mine is actually up in the high Andes. The tailings facilities are closer to the valley, but still relatively abrupt topographic terrain, which of course brings its technical challenges with it. Having said this, just to go over some quick descriptions of our tailings facilities. Quillayes is an older tailings facility, ultimate capacity of 400 million tons. It is a cyclone sand dam. It is currently inactive. It was built with the downstream construction method and currently has a maximum wall height of about 200 meters. It's not going to go any higher than that. It's currently inactive. Obviously, the mine is operating, and it does have an operating tailings facility, and that one is called Mauro, which is on the left. Mauro has an ultimate capacity of 1,700 million tons. It is also a cyclone sand dam built with the downstream construction method, and will go up to an ultimate wall height of 237 meters. This is significant height. It's close to world record heights for a cyclone tailings dam. It's not the world record. It used to be. It's not anymore. But it's pretty high up there, and obviously that carries its technical challenges. The next two facilities, as I mentioned, the other facility where we do have tailings is Centinela. This facility has ultimate capacity of 700 million tons. It is the largest throughput thickened tailings facility in the world at 95,000 tons a day. Containment is provided by two, I'm going to say a main dam and a secondary dam. The main dam is a rockfill dam. The secondary dam is an earthfill dam. You can see here in the front here, the main rockfill dam. Both dams are downstream construction, and the main dam, which is the largest, has a maximum dam height of 80 meters. Slide number 4, please. There you go. Oh, no, previous one, please. Finally, we have our Saldivar operation, which is mainly a heap leach operation, but it does have a small concentrator. Again, just to stress or to highlight the diversity that we deal with, this is a relatively small dam, 22 million ton capacity, earthfill dam, downstream construction, and has a maximum wall height of about 45 meters. So again, just before we move on to the next one, just want to point out that just you can see in the pictures and based on these descriptions, we deal with a diverse portfolio of tailings facilities. Very, very large dams in terms of height, cyclone sand dams, others are thickened tailings at very large throughputs. Climates are different, and I didn't mention this, but if you saw the first couple of pictures, maybe not shown in the pictures, but the two dams that we saw before are in important agricultural areas. So the social and economic context there is quite sensitive, I would say. Having two very large tailings facilities close to communities and to land that is relevant for agricultural purposes. So on to the next one, please. So I list here the main challenges that we see that are derived from the new standard. I'd like to say that AMSA participated significantly during the development of the standard, and now obviously during the implementation. AMSA is a member of ICMM, and as we heard from Diane, we have a commitment to be in compliance within 3 years for our critical facilities. The two first that you saw, both Mauro and Quillayes, are critical facilities due to their height and how close they are to communities. So those will be in compliance in 3 years. The other two, Centinela and Saldivar, are not critical, so we do have 5 years there. But we expect to hopefully have all four of them in compliance within 3 years. Having said this, I'd like to indicate that I think most major companies like AMSA, we don't see major challenges in implementing the technical criteria associated with the standard. Yes, we will have some gaps, but we feel that we'll prepare to address those within the timeframes that are established. So yes, there are challenges, no doubt, on the technical field, but we are of the view that these can be addressed, and we have the capacities to do so. And obviously, we welcome input and knowledge from service providers and new technologies to achieve that. So we do have a challenge, but the biggest challenges are the ones I indicate here. You've noticed that Diane did bring up two main aspects that we see as challenges. The first one is related to information and in relation to transparency. One of the big items of the standard is to providing transparent, accurate, and reliable and timely information to stakeholders. The information that is generated from these tailings facilities is tremendous. It's a huge amount of information. The standard requires us to be updating that information regularly, and so to be efficient about how we collect that information, how we interpret, how we analyze it. The standard also asks for updating. So we need to develop a knowledge base. We need to maybe not only develop, but we need to update. Anyway, so the generation of information is constant and regular, and all of it needs to be analyzed, needs to be interpreted, so it can be accurately, transparently, reliably, and timely informed to stakeholders, not only internal, but most importantly to external stakeholders. That public disclosure needs to be facilitated. So bringing all of this information together, collecting it, organizing it, analyzing, interpreting it, and then being able to put it out in front of the public to support meaningful engagement to project affected people, which is essentially what the standard asks us for, is something we see as an important challenge. So that would be the first main aspect. The other aspect, and you saw on the 4 principles.
Oh, hey, got 30 seconds. Sorry, we've got to run to a tight thing. 30 seconds, please.
Yeah, almost done here. As Diane mentioned, the 4 principles that she brought up talked about risk management or minimizing risk. That is another significant challenge that we see. Again, due to the wealth of information, significant amount of information, being able to analyze, interpret that, and passing that on to decision makers. Again, the other thing that we heard from Diane is that accountability is brought up to the highest level within the company. So bringing that information in a timely manner, digested and interpreted for those decision makers, very high level decision makers, to make those decisions is also a significant challenge. That's essentially what I had. Thank you very much, Paul.
Thank you, Jorge. Sorry to give you a hurry up, but it's very interesting stuff, and I know that people are going to have a lot of questions afterwards. I'd like to introduce Alex Petermann from the Mining Plus Group. So Alex is going to introduce each of the speakers. They have a 3-minute presentation and then a 3-minute question and answer after that. Over to you, Alex.
Good morning, and good evening, and good afternoon for everyone. Thank you for being here. That's a great discussion, and the 2 presentations that we had are brilliant. So I have a couple of questions here, but I'd like to just ask Diane. I live in Brazil, so I'm talking to you guys from Brazil, and I live about 20 kilometers from Brumadinho, and it's very sensitive to us here. The damage that the failure can cause, even if you see not just for the company, for the people that passed away, of course, but for the entire community, economy. So that's a lot of impact. What ICMM is currently doing in terms of communities and defining the standards are brilliant. I think that's something that really the industry was definitely missing. But how do you guys see these issues with communities, economy, and so on?
Yeah, in fact, thanks for raising. I kind of alluded to it in the presentation, but didn't go into details. But the community aspect is core and central to the standard. In the expert panel, there are 7 experts, and 2 of them are social performance or community engagement experts. And they worked very hard to make sure that the social performance aspects are integrated throughout the standard, and it's not a kind of as an aside but is really integrated into the whole decision making and transparency and disclosure with communities. And also there are other principles around emergency planning and response plans and long-term recovery plans. And those principles also have the involvement and meaningful engagement of communities integrated into the principles. So it's very much kind of the spirit of the standard. And so thank you for raising that. I probably kind of alluded to it, but didn't go into details in my presentation just now. Thanks.
Thanks, thanks, Diane. We're going to move on to the first presentation, and that is from Albert Cabrejo from Groundprobe. Over to you, Albert.
Okay, can you hear me well here?
Yes.
Okay, well, you see the screen is coming. Okay, so why are we here? We are trying to prevent catastrophes like these ones, or if they were going to happen, at least we should know that what is going on and have methods, technologies, processes, and plans to evacuate the people on time before these things happen. So this is a dramatic view of a few events that we all should be aware of. Cadia, that was not too much of a problem, Brumadinho, and San Marco. So this is what we are here talking about this. Next. Okay, so at Groundprobe, which is part of Orica Monitor, Orica bought Groundprobe a couple of years ago. We have an approach to recommending technologies in open pits, in underground, and which in civil applications as well, depending on the level of risk that we want to manage or that the customer needs to manage. So we go through this likelihood of occurrence versus impact common type of chart that we all manage for in risk management. And understanding the needs of the customers, we recommend a technology. And this is applicable, as I said, to many different types of structures, and including tailings dams. So if the customer, for example, just wants to understand how is the deformation conditions of the tailings dams, maybe INSAR is sufficient. So let's say at the beginning they just want to know what's going on, or if they already know that not much is happening and they just want to do periodic checks, INSAR will give that that type of information and service at a reasonable cost. But if the customer decides that they need to have a higher level of monitoring system for deformation, for superficial deformation, then we start escalating through GNSS, robotic total stations, synthetic aperture radars, real aperture radars, full support to geotechnical experts looking at this previous instrumentation, but 24/7 remotely or on site. And finally, after Brumadinho, Vale had the need of implementing system technologies for emergency management. So if there is a sudden failure, they needed a system that quickly trigger alarms so that people have a few more seconds or minutes to run away from the flood. And on the right-hand side, there are some images of the technologies that we are using in tailings dams. The SSR-XT, for example, we use at San Marco. The others, SRX, we are using a lot in Vale, and more recently, the SSR Velox, our new Doppler radar. Next.
30 seconds, Albert.
Sure, thank you. So these are examples of works that we are doing in Brazil. We were monitoring reinforcements of upstream tailings dams. The works are seen in the image at the left. The colors represent the formation towards or away from the radar, and we see some plots over there. So the software is programmed to allow you to discern between real movement and equipment noise. And on the right-hand side, we visualize the comparison between ground-based radars and satellite on vegetated tailings dams, long projects that we have been running for more since Brumadinho broke. So there's very good correspondence between different technologies, and it is paramount to have this level of redundancy in tailings dams, given the high impacts they present if they fail.
Excellent.
Thank you.
You, Albert. Back to you, Alex. If you got some thoughts or questions for Albert.
Yeah, Albert, thank you very much for your presentation. Great presentation. Well, I have some questions. I worked for a mining company in Mongolia, north of Mongolia, and the temperatures were very low there. So normally getting in the end of the year minus 50, minus 50 something. How does the technology works in those harsh weather conditions?
Okay, we have our radars designed to work on that extreme cold weather conditions. So we also work in Mongolia. We also work in northern Canada and also in China and Russia more recently, and Kazakhstan. So the temperatures that the radars work at over there can reach the ranges from minus 40 to minus 60 degrees in the more extreme conditions. And we developed the mechanisms to keep them warm enough so that they can continue working in such environments. There's no, that's for the equipment. In regards to the signal and the capability to measure displacements on such temperatures, there's no impact on of the temperature. It's more like the mechanical components, the ones that we need to keep warm. And it is a problem solved from years ago for us.
Excellent. Thank you, Alex, and thank you, Albert. Over to Jack Evans from the Hawk Measurement Systems.
Okay, thank you. Yes, I'm Jack Evans with Hawk Measurement, and I want to thank you for inviting us. Can we go back, Elaine? Oh, thanks. So Hawk is a 30-plus-year-old Australian company, and we've been developing technologies for the mining industry. Technologies such as continuous level measurement, block chute control, thickener bed level, and several other technologies. Our most recent, which is the fiber optic sensing technology, is now being used for conveyor health, pipeline leak detection, and now slope and tailings dam monitoring. Can we go to the, yeah, thank you. I'm sure I don't have to remind you of some of the recent failures. As Alex mentioned, the most recent devastating experience in Brazil was one of their worst environmental disasters. Of course, not to mention the loss of lives. So developing technologies for efficiency, preventative maintenance, and safety is critical for Hawk. Can we go to the next one? Thanks. So mining applications that we focused on are tailings dam failures, which are typically hydraulic failure events, and open pit failures, which are typically geotechnical and seismic failure events. Can we go to the next one? Thanks. So Hawk's fiber optic sensing for tailings dams uses a light source sent down a fiber optic cable. So it's a continuous measurement throughout the whole fiber optic cable. And the light source will be diffracted, which causes a backscatter where there's an event such as a temperature change, a vibration, or stress. Can we go to the next one? Thanks. So Hawk's technology is using the stress measurement to determine slope movement. The fiber is placed downhole through a structure of the wall to monitor the strain. The strain is detected by monitoring diffraction of light within the glass of the fiber optic cable. We use time of flight to determine exactly where the strain is occurring. Next slide, please. Thank you. So geotechnical slope analysis is conducted to identify the critical slip. A borehole pattern is designed to intercept critical slip plane and monitor the strain that we see in the field. Okay, great. And as an example, this is a simulation of strain and a slope during failure. Strain accumulation can be detected both before a failure and during a slip event. So some of the technology advantages for fiber optic would be it's 24/7 monitoring. The system provides unattended operation and it's maintenance free.
Excellent, Jack. Thanks. Appreciate that.
Thank you.
Sorry to give you a hurry up.
No, that's all right.
Yeah, I think we got to the end. Alex, back to you. Any questions or comments on that one?
Yeah, Jack, thank you for your presentation. Another great presentation. I'd like to do a link between what Jorge set as a challenge in terms of information generation. So we have a real-time system. So how do you deal with this universe of information?
So it is a lot of information. So that's what we do. We take information and we use our algorithms to determine the most important information to analyze so that it can be used for analysis of whether it's a open pit mine or a tailings dam. So it's an enormous amount of information that we manage and provide that analysis to the mine.
And a quick question from the floor from Mark Walker. Monitoring options following closure. He works in a wet tropical area and government is concerned about closed TSF and future failure.
I'm sorry, could you repeat that?
Sorry, monitoring options following closure. Mark works in a wet tropical area and the government is concerned about closed TSF and future failure.
Yeah. So the fiber optic cable is good for a long time. We've had fiber optic cable laid for many years, if that's the concern. And there's different kinds of cladding for the fiber optic cable to protect it, depending on the application. If I understood the question correctly.
Yep, I think it's an after event or after closure question. Thanks very much, Jack. Over to Gonzalo Suazo from GHD.
Suazo, yeah.
Sorry, Gonzalo.
No problem. Well, thanks, IMARC, Pablo, and Paul for the invitation. GHD is a global professional service company that leads through engineering, construction, and architectural expertise. The company was established in 1928 and we remain wholly owned by our people. We are more than 10,000 people, diverse and skilled individuals connected across 5 continents. In Chile, we were established in 2001, and since then, we have provided engineering services to different industries. So let's talk about tailings. As Jorge mentioned at the beginning of the forum, there's no doubt that Latin America is rich in base and precious metals. This intense mining production generates massive amounts of mine waste. As shown in the slide, Chile produces more than 1.7 million tons of tails per day, and we have more than 700 tailings storage facilities. Brazil, on the other hand, is believed to have more than 700 active TSFs, while Peru is constructing dams with heights of over 250 meters. Next one, please. In the light of the recently released standards, such as those presented today by ICMM, we have, as Latin Americans, a global challenge to face regarding tailings management from construction to closure. Next one, please. As GHD, we want to support our clients with these current and coming challenges. We've gained global recognition for our safe, cost-effective, practical, and innovative methods in design, management, and construction supervision. Our approach for tailings management, next one please, is based on concepts of risk management, governance, organizational stewardship, review and assurance, surveillance, and integration of new technologies such as paste or filter tailings. Our experience in tailings is large in Australia, New Zealand, and the Philippines, and now incipient in Latin America. In this context, in addition to current projects conducted by GHD worldwide, we've just signed a framework agreement for engineering services for water and tailings with our local copper producer, Codelco. regarding this, we strongly believe that future in the mine waste engineering services is bright for GHD in Latin America. Thanks, Paul. It's back to you.
Excellent, Gonzalo. And 10 seconds to go, so well done.
I try to manage my time.
Questions? Thanks, Gonzalo. Any comments and questions, Alex?
Yeah, thank you, Gonzalo. Well, I'm just thinking here. The engineering of tailings has changed drastically since the accidents. For you, what are the biggest challenges that the engineering service for tailings are facing right now?
Yeah, well, there are many challenges. First of all, we call it tailings engineer. Tailings engineers it's a broad word for something that involves hydraulics, geotechnical, geological engineering, and many other fields. So it's quite challenging to put all the knowledge into one engineer called tailings engineer. So for the future, first of all, we need to advance in the formation of human capital or people that knows how a tailings facility works. So that's challenge number one. And also there's a lot of changes in Latin America regarding tailings management, and mainly regarding risk management. We think we have to move forward thinking always on risk management of our facilities. Let's say from construction, operation, and looking forward to closure.
Excellent. Thank you very much, Gonzalo. Now over to David Smirk from Phibion.
Okay, hello everyone. My name is David Smirk. I run a company, an SME here in Australia called Phibion, and thank you to IMARC and partners for the opportunity to talk to you all this morning. Well, actually it's morning where I am. Okay, we were founded in 2006 in Australia, and we currently have offices in Australia, Jamaica, Chile, and Brazil. And we have one mission in our life, and that is we make tailings dams safer, smaller, and sustainable. And we do that using our rather unique technology, tailings supporting technology called accelerated mechanical consolidation. And what that is that we will take your pumped tailings of near any density, and we will customize a machine to be able to manage that, and we will plow and consolidate those tailings to high density. And the densities that we can achieve are rather extraordinary. In actual fact, we can start to approach the levels that you can only achieve through filtration. But what makes our technology a little different is that we do it without the need for our clients to spend any capital at all. So we offer this service to our clients, and from the day we start making a difference. And remember, this is all done with no capital. We don't interrupt your process, and we don't ask you to change anything about what you're doing. So what it means is that we can significantly increase the amount of water you recover. And in doing so, we can reduce the volume of the tailings that you've got, and also increase the density of those tailings significantly. And we can increase that density to such a point that we can generate considerable strength within the tailings. Put all that together, and we can reduce the size of the TSFs significantly. And more to the point, we can do it by reducing the additional facilities that you've got to construct, and thereby reducing your ongoing capital expenditure. And again, an outcome of our process is that we allow you to get very rapid access to the surface, which means that the day you close or the day you stop producing, you can get access to your surface. Next slide, please. So here's a little bit of a time lapse of a copper operation. And what you see there on day one is that tailings were placed in a layer of a particular depth, and we commenced our operations. And what we do is we plow from the point of discharge to the point of water collection. We start to create these surface channels. We call them scroll lines. And we repeat this process several times. And as you can see in that sequence, on day 43, we've effectively finished. And we know that because we walked out there and had a look. And when you start talking to clients about being able to safely access your tailings area within a number of weeks, as opposed to leaving it for considerably longer, it changes everything. Next slide, please.
30 seconds, David.
Okay, so where can we help in Latin America? There are significant and large mining operations. You have large risks like everyone else. But of course, for Latin America, water is critical. And that's one thing that we can give you. So we can recover water from your existing operations. We recover it from your tailings. And we do it at a lower cost than you can obtain fresh water from other sources. But you get all the benefits of tailings management for free, so to speak. So we'll reduce your volume, increase your density, and give you strength.
That sounds like a very good bottom line. Over to you, Alex. Questions and comments?
Yeah, it's a great technology. Thank you, David, for sharing that. I had the opportunity to see Phibion before, and I thought it a great solution for tailings dams and other applications. And what are the biggest challenges you see to implement this technology here in South America?
The biggest challenges. We're providing, or we're suggesting, something of a radical solution, which means that we need to bring our clients on a little bit of a journey. And we do that primarily by doing trial operations. So we have a machine enter into the site. And because every tailings is different and the performance that we can get from every tailings is different, we do need to come up with a unique solution for each site. But that can be done within a matter of months, and with all of the benefits that I described earlier. Once you have that base information, it is very easy to extrapolate that to a whole of site solution.
Excellent, thank you, David. Now our last presenter is Behrooz Garaman-Nahad from ATC Williams.
Hi everyone, and thank you IMARC and Mining Plus for the opportunity to present. With a team of over 100 highly specialized tailings engineer professionals at ATC Williams, our philosophy is to create smarter and safer storage solutions that, whilst meeting storage needs, offer both economic and environmental advantages. And there are obviously a number of elements that contribute to development of the best or successful tailing solution. And for us is always a holistic solutions required, to reach that point, to basically select the most appropriate tailing solutions, and a lot of elements going into it, from tailings characterization to the technologies and also regulatory requirements, and all of that just fit into the best tailing solutions. Next slide, please. And so these are the components of a tailings management, a storage facility, a tailings management system. Obviously, tailings thickening or dewatering, the amount of water that you separate from the tailings, has a direct influence on how it's going to be delivered to the site, and also on the way that is going to deposit on site. So if it's tailings slurry, it's going to be affecting the cost of pumping, and it's going to be transferred by pumping pipelines and flume. Or if it's filtered tailings, it's going to be basically conveyor belt or earth moving equipment and so on and so forth. And all of this has an influence on the retaining structure at the end. If it is a tailings slurry, you need a retaining structure. If it's filtration, or filter stack facility, you need earth moving equipment, and essentially that could be a tailings, storage, a tailings dam itself, because you have to place the material in layers, and also compacting the material. And usually, the combined costing of these top three, the tailings thickening, the watering, tailings delivery, and retaining structure, decides the most economical option. Always, as indicated, a holistic approach is required when selecting the most appropriate tailing solutions. Next slide, please. And next slide, please. So there are several stages of a TSF life, as you all know, and each stage should be adequately taken care of for the best and successful outcome. So you may have the best design, but if it's not constructed properly, then we have problem. If it's not operated properly, we have problems. So everything, needs to be, taken care of for all of the stages of the mine for the TSF life cycle. And the performance should be considered from cradle to grave, what we call it. And the earlier, we get involved, greater values can be added to the project. Next slide,
30
please.
seconds, Barris. 30
Okay,
seconds.
no, I'm almost done.
Thanks.
So depending on various considerations indicated earlier, including site constraints, the tailing solution may vary. I mean, you can see in this image, we have, Cross Valley, tailings dam with 1 billion tons of tailings storage at Sacheshme, or, plus 200 meter high, tailings dam at Las Bambas in South America, or, the central thickened discharge scheme in Sunrise Dam at the bottom picture, as you can see there. And by the way, we were, the pioneers of the, introduction of the central thickened discharge scheme in Australia. That's all I have at the moment. If there's any questions, I'll be happy.
Yes, Alex, thoughts or questions?
Yeah, Barris, thank you for your presentation. Very good presentation. Yeah, I have a question here. I think it's something important as well for Jorge in the Antofagasta Minerals or any other mining company that has TSF facilities. So, for example, what we see here with the dams here near Minas Gerais and in Brazil, you have TSF facilities that takes 40, 50, 60 years from commissioning to closure. How do you see the management of this process during this time? Because you have people joining the companies and leaving and changing information and changing technology. So how do you see that?
Yeah, that's a very good question, Alex. Yeah, it's we see all the time, people changing, but that's, I believe, the purpose of all of this governance structure, which has been introduced recently through even ICMM. So if the governance is there, so change of people shouldn't make huge difference. And we can see that this is changing, all of these governance playing a major role in the way things are operated. So I'm sure that in any mine, several people, change, and even mine itself change hand, it's bought by others. But if you have a proper governance system, that's going to be taken care of. I mean, right from the start to the end, what we call, having an engineer of record, for example, in there, basically having all of those stories of the tailings dam from initial investigation, designs, and operation all the way to the end. So I hope I answered your question.
Great, thanks, Barris. Now, Jorge, you've seen the presentations. We'd like to hear your thoughts.
Sure. I'll just maybe tag along to what was indicated just recently here. And that was a good question from Alex, because as I mentioned, it is a challenge to be able to manage all the wealth of information, as I said, and because that information needs to be regularly updated, as I said. But as mentioned, these facilities have very long life cycles. People change. Managing that information so it's up to date, so it's not lost. Management of change is critical, and what I mentioned as a challenge earlier is part of the things that we need to implement effectively to be able to resolve it, aside from the governments, as mentioned. I'd just like to add that these were very interesting presentations. We touched on several subjects from instrumentation, monitoring, and also engineering capabilities. All of these technologies are very useful. We saw a few there that are, I guess, on our end, we're implementing these. Again, the challenge still remains is to how that wealth of information is managed appropriately and interpreted so it can support risk management decisions at very high levels. So that is all very useful and very valuable, and obviously the requirements of the standard, of the new standard, will require that instrumentation monitoring is going to be increased as we go forward to increase that level of information, as we just said. And then I think we discussed about engineering capabilities also. There's a big lack of engineering capabilities. There's changes in the industry are frequent. Hopefully those will diminish going forward here. But again, the continuity of engineering companies within the industry is critical to maintain a good level of governance and to maintain, I guess, the knowledge in one place. Finally, I just want to mention the Phibion. And we are actually testing that. We'll be testing the equipment. Hopefully, I'm not completely up to date on the specifics on that, but I know our folks at Columbus are looking into this option, and we certainly have high hopes that it'll work because, as mentioned, water is a critical resource, and so we're doing, and the whole industry is doing their best to improve water recovery. So we're looking forward to that, and other technology. Thank you.
Thank you, Jorge. Just a quick question from the floor to Gonzalo and then to Beirut. Gonzalo, do you have an internal TSF audit standard? Is it based around ICOLD, CDA, or ANCOLD? Elaine, if you can unmute.
You're answering Gonzalo, or do you want?
Yeah.
So what was it? So do we have an internal? Can you just tell me the question again, please?
Yeah. Do GHD and ATC have an internal TSF audit standard, and is it based around any particular international standard?
Yeah, certainly. Yeah, we have our internal standard, but we're mainly following, ANCOLD, Australian National Committee on Large Dams standards, which is pretty much very similar to the to other standards. For some sites, of course, we've been asked to use certain standards. For example, for BHP, sites, we usually get asked to use Canadian Dam Safety Association standards. But from now on, I think pretty much there'll be a push for adoption of the global industry standard on tailings dam from various operators. But how quickly we get to that, I don't know. But we're pretty much trying to follow the standards.
Thanks, Chris. Gonzalo?
Yeah, sorry, for some reason my mic was blocked.
Okay.
Yeah, we do risk audits based on it depends on the country. If you go to South America, in Chile, you have something that is different to Brazil. But in general, there's a kind of umbrella. So we follow ICOLD in America, ANCOLD in Australia. So yeah.
Excellent, thank you. And look, that wraps us up for today. It's right on 10 o'clock, so we've done well on the time. Thank you all, especially Jorge and Diane, for your time and presentations. A big thank you to the Victorian Government and Mining Plus for their ongoing sponsorship of the METS Arenas, and hopefully you get more out of today as the day goes on. We hope to see you all again soon. Bye all.
Thank you.
Thank you.
Bye. Thank you.
Thank you very much.
Bye. Thank you.